All right, so moving forward, we will assign that vocabulary on Monday, which I don't know how many there are. We spend a little bit of time talking about the viruses, but it's more so vocabulary that's enhanced with that rather than talking about it. Because I know it's been brought to my attention, there's two terms that aren't there. One's gram positive, one's gram negative. We'll go ahead and address those today. So I'd say if we assign that on Monday, probably due on, I'm thinking Thursday, just on account of, again, who knows? It doesn't take much snow. If the wind picks up, I know, talking with some of the upperclassmen and those you individuals that are living on farms, it's tough when it's like this. 16 inches of snow is no small feat, but down in our neck of the woods, it was 26. So, and where do you put that snow? I know, and it just compounds the amount of work that needs to be done. And it's something that you can't plan for, especially if it's increasing your fuel costs and operating costs on your farm. Okay, so this is approximately where we left off.
I usually just use my sprayer, put hot water in there.
Okay. Okay, so I changed the design template to match more so what last chapter was. Haven't quite figured out. I think I need to move that up a little bit on some of these. Okay, I think this is where we left off with, correct?
Yep.
Okay.
Stop saying that, Chris. Saying what? Well, when the door would be open, man. Stop. Open the door.
Oh, you need a paper, I bet. Yes, I will. Shoot, that's supposed to be white blood cells down there, but you probably figured that out already. Must be the one. Yeah, and it is just a front and a back. That'll get us started. Okay. So when we say these bacteria are encapsulated or there's a capsule, what does that mean to you?
Capsule. ACO. Good off.
Thank you. Okay. What did you say yesterday? You were right.
The round deal that has powder in it.
Yeah. So you could say different types of over-the-counter pills that may be prescribed that are encapsulated in a type of material that just breaks down inside your digestive tract. If you take a lot of it. But well, it's hard on your liver because if you take it in excess, you got to break it down somehow, and that's what your liver does. Okay. So, this is new material. Now, again, we have a job here. Just let me help you. All right? Because when we get to your microbiology section over in the lab, a lot of you, some are really good at this, some are really not. Some that are not are whether they don't care or are careless, or could be a variety of reasons.
Mr. McKinney, are we ever going to dissect anything?
Not so much at this level. It's more so zoology and A&P.
So you're saying I should take zoology?
I didn't say that.
Dissect them.
You know if there's more than one way to skin a cat?
Well, that's what I've heard before. So, when we look at this, okay, these pili, just look at their like tiny fingers that stick out, and what they do is it's a reproductive function, because let's say, for instance, Playing a game every day?
No.
What happens if you lift that? Maybe nothing.
Playing his belt buckle.
hmm
Oh.
So we got to play these games too, huh?
I think it was just
All right.
folder.
So to me, this is probably more common in swine or pigs as maybe opposed to bovine or cattle. Okay? And that is maybe after farrowing, and farrowing means that you're actually raising infant pigs to maybe to feeder pigs, or maybe you feed them all the way to you say fat cattle, fat hogs. I don't know if fat sheep is a term as well, but you're bringing them to that type of a market. But after successive generations, why would you want to swap out new female pigs or one or two new male pigs? What does that do? Yeah, I wouldn't say it increases your gene pool, but what's maybe a better way of looking at that?
More variety.
Yeah, there we go. There's more variety in there, okay? So what happens is if these form these bridges between these cells and they start exchanging genetic information, it allows those bacteria to possibly adapt, if you want to call it that, and it increases their genetic variability. The problem with that is, okay, sometimes when it comes to science and medicine, we got to play catch up, okay? So you could go perhaps all the way back to the 1950s, 1960s. Kind of ties into your ibuprofen question, okay? For some reason, somebody's got a bacterial infection. They go to the doctor and they will prescribe what? Like amoxicillin is a what? Does anyone know? It's an antibiotic. Penicillin, antibiotic. Tetracycline, antibiotic. All those maybe have different types of functions against different types of bacteria. Okay? But the problem with that is, of course, we know this now, is 2 pills, which may be 500 milligrams each. So 1,000 milligrams did the trick. Then maybe 5 to 10 years later, 1,000 milligrams isn't doing it, but 1,500 to 2,000 milligrams does the trick. Okay? So then, yes, it's building up a tolerance. Oh, okay. So if you continue to build up that tolerance, does that make that antibiotic worthless?
No.
To that individual, it probably does.
Oh, yeah.
But what we're getting at is if that happens to enough people, the strain of bacteria is going to become resistant to different types of treatments. So that's what we know now, but it's unfortunate that antibiotics were overprescribed for multiple years, because typically it's probably what's going to happen is if these genetically modify themselves, what used to work is no longer an option, okay? Because some of these do become what we want to call antibiotic resistance. And oddly enough, the worst infections may come from where? And you would never think this. No, what type of an environment that you might be recuperating from? No. I haven't heard it. I don't think I've. No. No. You're getting a little closer. No. 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 It's a time. It's not a grocery store, not a school. Who said hospital? Okay. Some of the.
I said it before you. Yeah, I did.
Okay. So what happens is some of the worst bacteria that you can come down with as an infection is actually coming from the place that's supposed to be the safest. Okay? That's usually what we call post-op infections. And what that means is post-operatory infections is after the operation, different types of strains of bacteria can be found in the hospital, and that's where you think that should be the cleanest. But that is not the case. Now, but some people believe it, and like myself, okay, is there any way that you can remember back that if some sort of toy or anything that fell on the ground, I remember like pulling carrots straight out of the garden, trying to wipe, and I was probably 5 years old, wiping all the dirt off and then chewing on the carrot, and you hear the grit of the dirt and everything else inside your mouth. It might sound disgusting, but is that healthy? At that age, yes, because what does that do? It definitely builds up your immune system, and it does. As a society, have we possibly gotten away from that? Yeah, I think that's certainly a possibility. That would have nothing to do with it. Okay, so when we talk about these different types of shapes, okay, I don't know if being it's called med tech, but you could say a medical technician, that used to be a very popular profession, probably in the early 2000s, and maybe getting into the early 2010s, 2011, if you understand what I mean. I'm presuming that it's still a type of profession, but one of the things that the doctor might order is a type of procedure to try to diagnose some of this bacteria. So you do a gram stain, very similar to what you will be doing in, I don't know, 2 weeks from now, 3 weeks. I can't give you a concrete date because we got to get through the project of the plague, okay? Because that ties into this curriculum as well. But you go through a specific procedure where you are staining these bacteria. And what you would do as a laboratory technician is not only are you looking at the shape of that bacteria, but how it reacts with different types of the gram staining procedures. And that, again, is part of your vocabulary, and we will go through that here in just a moment. Okay. I think, still, okay. This I want to get through, especially this slide right here. And yeah, that will be it, just down to here. Okay? So what it's saying is, so prokaryotic characteristics, does that have a nucleus?
Yes.
No, it does not. Eukaryotic cells do. Okay? So one of the aspects that you will learn if you take anatomy and physiology is when you're talking about anything that's peptide based, or if you're taking biochemistry as well. If it's some sort of peptide base, it's a type of protein, okay? And the reason that that is so significant is because if there's a large amount of this substance in the cell wall of this bacteria, it will allow you to identify what type of procedure it is, if it's pink or purple. Okay? And that's what we mean by being gram positive or gram negative. And again, we'll illustrate that here in just a moment. So down to here is where we will stop. Okay? Does everyone have that content that wants it? Yes?
Hang on. Yeah.
Okay. I didn't know if we're going to get to the books today or not. All right. So, we'll start with the inner portion of these bacterial cells. Okay. You don't need to draw these unless you think it's relevant to. There's probably pictures of this in your book as well. unless it's entirely up to you.
Would you write this down?
Yeah, maybe, but I'm not going to walk around to say, you should be writing this down. I'll let you be the judge of this in just a moment. Okay. Just at your first observation, what is the size isn't the answer of the size of these cells, okay? Not only just the color, what else?
How many?
Okay, so the rings has something to do with it. Okay, so the reason that this is significant, okay, rather than coloring this in like this, I'm not going to do that. That's why I go around like this, okay? So what was one of the things that said if a bacteria is gram positive? And why is it that it's dark purple right above that? There's a lot of polypeptides in there, or protein, in this cell wall layer is really, really thick because it's composed of that peptidoglycan. So, if you were to hear the color violet, what does that mean to you? Violet is purple. So in the gram staining procedure, and again, we'll go over this at a later time, have you ever, is safranin an actual color? Do you?
Yeah.
Okay, so what color is safranin?
Kind of like a pinkish.
Exactly. So what happens in this process of gram staining, where you got purple and you've got pink, okay? When you start with this process, crystal violet is your first step. And since this cell layer is so thick, composed of that large amounts of that peptidoglycan, once you put this grams iodide in here, that seals all of that purple in there. Okay? And it will not wash away because of this decolorizer. But what happens in gram negative bacteria, okay, in this inner cell layer, notice it's not as thick. So this gets stuck inside of here. Okay? And then in the counter staining process, this pink that you, did you say pink? One of you did.
Yeah,
Okay? When you counter stain this pink gets locked in the outside. So when we talk about gram-positive bacteria, they appear as being purple. So this is gram-positive because of all this purple color that gets locked on the inside. And then this is gram-negative because it's pink. Okay? That is why...
Is all that pink or just the outside?
Just the outside. Okay? Because what happens is one of the things that this is so reliable as far as a diagnostic tool, one, it's quick. Two, if it's quick, it's efficient. And three, it's very accurate. Okay? And it's cost effective. Some processes that are not, usually don't use cost effective and efficient and reliable in the medical profession, especially cost efficient. Okay? So when you get different types of bacteria that you will have to do both of them correctly. A gram-positive bacteria, that's going to be purple, and then a gram-negative bacteria that will appear pink.
Could it be pink on the inside and the outside?
No.
So
Only if you do it incorrectly. What's that?
So on the inside it's purple, on the outside it's pink.
If it's gram negative. Because what happens in gram positive bacteria, this gets locked in here and cannot get washed away to turn pink if you do it correctly. Now, this is not one of them aspects to where you do one of each slide and then you get evaluated. You practice this for probably 3 days, maybe 2 to 3 days. Then what happens is you take a slide and say, I'm going to get I want to be evaluated on this gram positive. It's called Micrococcus luteus, or ML. Okay?
It's something funny.
Okay? And then the other is E. coli, I think. The other strain is E. coli, and that will be pink. So what's going to happen is we look on the slide. Okay? This is a glass slide, and here's your bacteria. We look all over on that slide. If this is what it's supposed to look like, but this is what we see, you're probably not going to want that grade. Okay? But like I said, you're not going to be evaluated this on the first time. Probably not the second time. Maybe about 2 days after practicing, you become proficient at it. Yes?
Where are we going to get the bacteria from?
Flynn Scientific. It has to be a pure source. Because we can't scrape bacteria up off the floor. Why not? Well, you can. No. You might have all different types of bacteria, all different types of strains, shapes, colors. You have to have a pure bacteria that's not contaminated. That's why. Okay?
But like a professional would be able to name some of those bacteria on the board?
I suppose after doing different types of sugar tests, I know that's one of the aspects that you have to do in microbiology. That's one of them. Obviously, this test, what does it do when it's refrigerated? Different types of tests like that. Okay.
Tests like that for any classes?
Sorry?
Do you do any tests like that for any classes?
That's a college level core test. Okay, so bacteria. Vocabulary due next Thursday, the 12th. Some of you have it done already, okay, which is great. One less thing to have to worry about.
Are you going to do the 2 words?
We did.
We just have to draw that?
Okay, what you want for gram-positive bacteria, what do they look like? Purple. Gram-negative bacteria, what do they look like? There we go. All right. That's all I have. We'll catch up to you next time.